Allow me to share a tale with you about quantum computers that sounds so amazing that it almost seems like science fiction. In a world where technology is continuously pushing the envelope of what is possible, NASA shut down a quantum computer after an insane incident occurred. We are on the verge of another revolution that could lead to amazing advancements for our species. But quantum computers also present a risk that is hard to predict, particularly when combined with artificial intelligence. Will machines soon take over everything, or will this technology only benefit us? Visionary and multi-billionaire. According to Elon Musk, the combination of artificial intelligence and quantum computing presents a huge opportunity for humanity. In addition to bringing about amazing technological advancements, quantum computers can improve all aspects of our lives and solve problems that were previously unsolvable because of their capacity to perform calculations at a speed and complexity that greatly surpasses that of traditional computers. Everything from medicine discovery to encryption might be drastically altered by quantum computers, but this amazing potential also brings with it hitherto unheard-of difficulties and moral dilemmas. The potential for quantum computers to crack current encryption schemes is one of its most intriguing and concerning features. These systems serve as the foundation for all of our digital security, using the capability of quantum computers to safeguard everything from government secrets to online banking. Shor's algorithm, a security mechanism that can factor big numbers fast, might be broken. If this technology gets into the wrong hands, we could be facing a cyber war, and chaos would spread throughout the entire world. What exactly is a quantum computer? This could threaten the security of private data and the security of our entire world, which has proven difficult to predict thus far. Consider a typical computer that does calculations using tiny components called bits. These bits are similar to tiny light switches that may be turned on, which represents a 1, or off, which represents a 0. The computer performs a variety of computations. A quantum computer makes use of qubits. Similar to tiny switches, qubits have the ability to have a significant impact. Since they don't completely occupy any state, they can be somewhat on and off at the same time. This makes quantum computers more than 1,000 times more powerful than regular computers. But because qubits are extremely sensitive, they require complete silence and cold to perform at their best. For this reason, quantum computers differ greatly from standard PCs or laptops. The quantum computer is tiny in and of itself. However, with their many tubes, the cooling and buffering is a significant concern. The first quantum computers had an odd appearance. Naturally, quantum mechanics in physics is the source of the quantum in a quantum computer. Quanta are light particles and atoms, which are even smaller units of substance. According to quantum mechanics, these quanta can occasionally behave like waves, exist in multiple locations simultaneously, and only transform into particles when measured or observed. This may sound absurd, but it is precisely this property that enables quantum computers to perform calculations far more quickly than any conventional computer. Scientists who were considering these peculiar characteristics of quanta came up with the concept for quantum computing. Richard Feynman was a pioneer in this subject. This outstanding scientist was one of the driving forces behind the creation of quantum computers. His impact can be primarily linked to a speech he gave at the 1981 physics conference in Utah, titled Simulating Physics with Computers, in which he proposed the notion that physical processes could be simulated using computers based on the principles of quantum mechanics far more effectively than with traditional computers. Feynman maintained that since quantum events are so complicated, they cannot be adequately simulated by ordinary computers. He proposed that a computer that makes advantage of quantum features, or a quantum computer, would be able to do this work much more successfully. Since quanta, the fundamental units of our universe, are most likely also magical information carriers, this concept was groundbreaking. This implies that a quantum should, in theory, be able to access the universe's blueprint, in addition to using quantum physical phenomena like entanglement and superposition to address difficulties in daily life. Computers would most likely be able to provide us with access to information that we now lack. A quantum computer could not only solve existing problems in astrophysics or show us how the universe really began, it could also help us, for example, to find new medicines or predict the weather with certainty. It's a bit like having a super clairvoyant to help us solve the most difficult puzzles, a state of emergency at NASA. Imagine how quantum computers are revolutionizing space travel with their unprecedented computing power. Quantum computers could perform complex simulations of space missions, mathematically reproduce the dynamics of galaxies 100%, or design new materials for spacecraft that can withstand extreme conditions in space. They could also help analyze huge amounts of data from telescopes and space probes, and no discovery, no matter how small, would escape us with a little training. And combined with artificial intelligence, a quantum computer could explore space autonomously, like a super scientist, and provide us with all the data we could possibly want. But with this incredible technology comes risks. It would be easy for terrorists to take control of entire spacecraft, and tampering with the data or control systems of spacecraft and satellites could result in malfunctions or even the loss of extremely expensive objects like the James Webb Space Telescope. If NASA were to use a quantum computer, spies or sabots with their own quantum computer could gain access to NASA's systems and steal or manipulate confidential information about space missions, advanced technologies, or national security data. This could jeopardize not only NASA's missions, but also the security of national and international space projects. To deter abuse and terrorism, quantum computing systems at NASA and other significant institutions would need to be closely watched and well secured. The challenge is to maximize the advantages of quantum computing while minimizing the risks. Therefore, quantum computers are a balancing act between our constant pursuit of progress and protection against the potential dangers that this advanced technology brings with it, such as technical superheroes. Despite these concerns, however, quantum computer technology also offers incredible opportunities in drug research. For example, quantum computers could help analyze complex molecular structures and develop new drugs faster than ever before. Post-quantum cryptography is a new kind of encryption that is being developed by specialists and scientists worldwide. These systems are intended to defend against possible threats from quantum computers. Post-quantum cryptography is an encryption technique that is impenetrable even by the most powerful quantum computers. As a threat increases, a defense mechanism is developed, but we also had no idea what lay ahead because of the internets and the world's increasingly extensive networking. Nevertheless, both innovations have advanced and are now commonplace, and we must admit that our world has benefited from them overall. Similarly, with quantum computers and encryption technology, we will have to continuously redefine the parameters of security in the digital world. But we will do so, and eventually, quantum computers' exceptional computing power can also help us to create more security. A deadly combo. Take a moment to think about the potential for integrating these supercomputers with artificial intelligence. In the future, quantum computers, with their capacity to execute intricate computations at a breakneck speed, could theoretically aid in improving the precision and dependability of AI-driven responses. This would be especially crucial in fields like medicine, where accuracy is essential. Whether it's law or finance, these two technologies have a bad side. Quantum computing and artificial intelligence together may provide hitherto unidentified risks and misuse potential. Deep fakes, which are deceptively re-looking forgeries of image and video content produced by AIs using the processing capacity of quantum computers, are one concerning example in this field. We could be living in a future where false news and fakes are almost identical, which might have disastrous repercussions. Deepfakes could be even more convincing and difficult to spot. Consider a video in which the President of the United States or another powerful figure makes a hostile or provocative remark about another nation. Considering the current global climate, this could be a grave insult to another head of state or even a declaration of war, with potentially lethal results. With the aid of AI technologies, the video would be so convincingly faked that it would appear real to the untrained eye. It would then be shared on social media and news channels, Or computers would break into the websites of well-known news organizations and spread it even more realistically, potentially causing disastrous reactions. Global stock market unrest. Before the fraud could be discovered, there would be panic, diplomatic problems, and maybe even military reactions to save the Earth. Who would have imagined that quantum computers would eventually be crucial in the battle against climate change? Some of the most urgent environmental issues of our day may be resolved with the aid of these very powerful computers. Imagine using quantum computers to simulate incredibly detailed climate models. These models could help us better understand weather phenomena like El Niño, or calculate the long-term effects of greenhouse gases. They could also predict the effects of various environmental factors on climate with a precision that is impossible with conventional computers. Emissions. On global warming, future iterations of these devices would probably also assist us in resolving the issues. Where are the deciding variables, and are there methods to affect the climate? If a quantum computer has the right software, this shouldn't be an issue. With its computational capability, quantum computers might lead to the creation of more effective solar cells or the discovery of novel techniques for CO2 collection and storage, among other environmentally beneficial technologies. Although it is already apparent that these computers would raise security issues, we still need this technology, because quantum computers might improve energy distribution systems to increase the efficiency of renewable energy sources like solar and wind. Recent years have already seen tremendous advancements in the creation of quantum computers, with IBM and other businesses producing some of the finest versions. The very expensive quantum computers will likely be available in the cloud system at some point. You can just buy or rent your share of one of these supercomputers, and quantum computing will be available in your home. However, these machines are still a long way from becoming commonplace machines. They are primarily found in research laboratories and are not yet suitable for general use due to their size and complexity for average users like you and me. If you want more exciting and up-to-date videos, subscribe now.